Okay, now you have seen linear regression, both simple and multiple linear regression. Okay. So we are going to see the next type, which is the logistic regression. It also have two kinds. One is binomial and another is a multinomial. Right, let's start with binomial. Actually, logistic regression um, is computed if your dependent variable is binary. Dependent variable on y-axis is binary. Example, um, let's see, maybe uh, among performance, we have past student who maybe pass above 50% and failed student maybe who got lower than 50%, right? Binary something like 0 and 1, 0, 1 and 2, those categories, but categories in dependent variables. We need to note that when dependent variable is category, we compute logistic regression. Okay, which is different from linear regression. In linear regression, dependent variable was continuous data. But for logistic regression, dependent variable is a categorical variable. All right. Now for logistic regression. Logistic regression. The formula is just like the multiple regression. Logistics regression. The formula is, instead of using LM, linear model, we use LGM. Where are you? LGM. Oh no. GLM. General linear model. The output as Y filled with predictors x1 plus x2 plus x3 plus other variables. Then data you need to put your data name. All right. Okay. Now let's see, among our variables we have predictors such as gender, accommodation, grade, and you have outputs such as performance and income. So these are continuous. So we can change one of these, performance or income, and change into category. We can change performance into two categories, passed and fail. All right. So we need first to categorize the data. How? we can call this one maybe the same data new data file and data from our data file. Let's pipe it with mutating. We are going to change this column and categorize it. Mutate what? Mutate. We can create another name. If we want to retain the same name, perform, you can use this name. But if we want to create another column, we can bring another name. Let's call it path fail column. This will be using if else function. Let's call the real column, which is performance, and we need to take data which are greater than or equal to 50%. Call these data pass. Okay. Otherwise, call it fail. All right. Okay. If we run this code, we can see in our data we have created another column called pass fail. Having fail, pass, you see 41 it's fail, 66 is pass, like that. Okay. Now we can go ahead and continue with our formula. Logistic regression. Logistic regression. General linear model. Now our y or output variable is pass fail column tilde with, you can use what we used on multiple regression, income plus gender plus accommodation. Okay. Then our data, which is data new. All right. Let's run this. Why the error y mu non-numeric argument to binary operator. Okay. Now this one is telling us that our column we are using is having string variable or text, so we need to change it to numbers. All right. Now how? Can come here, change data to numeric. Okay, how? Our data file is data new, use $sign and call that if column, it's pass fail column. Okay, we use if else function to call if else function to call our data, which is data new, and that specify that column is pass fail. All right, this one use double equal, and where it is written quotation mark pass, call it 1, otherwise call it 0. All right, so it means that we have in the pass fail column, we have fail and pass, fail and pass. So we are telling our software to check where we have pass, replace it with 1, and where we have fail, replace it with 0, so that they are numeric to be computed with our function DRM. Okay, if we run this code, you can check, you can see our column now has numeric values. Now if we go back to compute our regression, it can work and it can't provide any more error. So let's summarize the results. Logit regression, and we see what we have. All right, what we have? We have our formula here. We have deviance residuals as we had. We have coefficients as we had. We have significance code as we had before. The new one we have here is the dispersion parameter for Gaussian family. All right, and the number of feature scoring iteration. Now, for more specific, we can come here and edit our formula. We can use family, in which family we are computing this data is binomial. Put this in the quotation mark. Okay, no many things will change here, but it just we are certain. Yes, as you can see, iteration has changed, but the results are the same. But we are certain that what we are doing is correct. All right. Now, other things are similar, but interpretation of deviance and the AIC. AIC is the archaic information criterion, and this deviance and the AIC shows that lower values of deviance and ARK indicate better model fit. So the residual deviance of how much do we have? We have 71. Suggests that the model explains a reasonable amount of the variability in the data relative to the null model. So based on this output, income and the gender, here, income and the gender, do not appear to be significant predictors of pass and fail in this logistic regression model. Only accommodation, interpreted as having accommodation on the day or assessment, shows a significant effect on the odds of pass-fail.